Why, hello. It's been a while. Let's fix another MacBook. Here, we have a MacBook that needs to be fixed. This is a MacBook Air. This MacBook Air has liquid damage. Let's take a look at the board. Get an idea of what's going on with this little MacBook. Looks like we have some fairly obvious liquid damage up here. I gotta say, I'm loving this new lens. It does show how unsteady everything is, including my hand. Also, sorry that I haven't been as frequent with videos recently. It has been very, 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 very ungodly busy, and there's been quite a bit to do. I also had to get my PC fixed, but I finally have a nice little water cooling setup here, even if it doesn't quite fit into this Corsair case the way I would want. I never have to worry about this machine going vroom, vroom, over and over again anytime I hit start streaming, because that Enermax pile of trash liquid cooler is now gone. So, yes, I'm dumb. I'm the dum-dum that bought the Enermax liquid cooler. I'm one of the 5 idiots that bought that pile of crap. But it is now gone. So the first thing that we need in order to get a light in the charger is PP3V42_G3 hot. Let's open up a board view for the 820-00165 MacBook, and see where PP3V42_G3 hot is. If you don't know why PP3V42_G3 hot is supposed to be the first rail that shows up in this MacBook, I highly suggest that you check out my videos on the one-wire circuit on boards.rossmangroup.com, because if I explain why you need that power rail even one more time, I might just have an aneurysm. So, as you can see, PP3V42 is going to be over there, over here, over there. So let's see if it's present on my board. And it's not. Now we're going to see if we have a short to ground on PP3V42_G3 hot, because a short to ground can keep it from showing up. It's not shorted to ground. 10 kiloohms. What could it be? All right, so now we have to find the PP3V42_G3 hot creation circuit. And take a look around. And let's see why it's not being created. U7090 is the chip that's going to create PP3V42_G3 hot. And it needs to be getting voltage as it's enabled. It's enabled and its input pin. As can be seen over here, the voltage in pin is pin 6. And it's supposed to be getting either 8.6 volts from the battery on its PP Bus G3 hot, or if the battery's dead, it's supposed to be getting 18.5 volts from the charger. Let's see what it's getting on pin 6. We're going to move the microscope over. Wow. Much corrosion. Much corrosion. Let's see what we're getting on input. Seems like we're getting 0.1 millivolts on input. No good. We checked over here on the diode, pin 3. I wonder if there's a short to ground over there, because do keep in mind, there are not just capacitors on output. There are also capacitors on input. Capacitor C7091, capacitor C7090, and capacitor C7092. So that can actually be shorted to ground as well. We're going to put our multimeter back into impedance mode, resistance mode, #resist mode, and see if we have a short to ground over there. We don't. 5 kiloohms to ground. Looks like we have to go further up the chain to figure out what's wrong with this MacBook. All right, I'm going to plug my charger in again, put the multimeter into voltage mode. Let's see what's happening behind the diode. Now, I don't expect to be anything on the PP bus yet, because we need PP3V42_G3 hot before we get the PP bus. So before we get to ride the PP bus, let's check out PP18V5. That's the voltage that's supposed to be coming in from the charger. That's supposed to be present on pin 2 of the diode. And pin 2 of the diode is going to be the left pin. Nothing. Wow. Okay, let's continue our journey upwards. Now, what's feeding pin 2 of the diode is going to be R7005, a 10 ohm resistor. Let's find that 10 ohm resistor and make it stop resisting. So, what do we have here? 0 volts. It's not the resistor. Okay, let's continue up the chain. Let's continue up the chain. Now, Q7010 is a transistor that's going to open and allow this to come through. So, let's take a look by making this full screen for a moment here. Now, Q7010 is a P-channel MOSFET. The way a P-channel MOSFET works is it's going to allow power to go through when the voltage on the gate is lower than the voltage on the source. So voltage is going to go from the source over to the drain, or current, or energy, or wattage, or grrr. I'm going to just start going grrr. There are some engineers watching the channel that have gotten angry. The fact that I'll say current instead of amperage, voltage instead of amperage, power instead of amperage. From now on, I'm just going to grunt. Grrr! Super male vitality. So this is going to allow the power to go through when the voltage on the gate is lower than the voltage on the source. Now here, we have a path to ground for the gate. R7011 and D7012 provide a path to ground to lower that voltage a little bit. R7010 and R7011 are going to allow some voltage to go to the gate, but if this diode is doing its job, that voltage is going to be brought down by a little bit, which will allow this to open and get the job done. Now, the way I know this is a P-channel MOSFET, if you're unaware of how I would figure that out, is by Googling it. So I'm going to right-click and do that. Then I'm going to go over to my web browser, and I'm going to search for it. And if you search for it, the first result on Google, which I should really stop using and change it to DuckDuckGo as my default because Google are blah, is a P-channel. That's how I know that it's a P-channel and not an N-channel. There are some people who have a brain, unlike me, who know that this is a P or an N channel simply by looking at the internal picture. And I've been doing this job for damn near 10 years, and I forgot how to tell. Don't be stupid like Lewis, but also realize that if a stupid person like Lewis can figure this out and do it, you can too. But back to the schematic. Now let's see if Q7010 is doing its job, or if it's not being told to do its job. So I'm gonna check the power at the gate and the source. I already checked the power at the gate at the drain. I checked it right over here, and I didn't have nothing. So we're gonna check at the gate and the source. Let's go back to the view that's split. MacBook, that needs to be fixed. 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 MacBook, 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 MacBook. Let me pet your BlackBerry. Nobody pets my BlackBerry. BlackBerry does not have a price. How dare you? She's my angel, my princess. A mere $2 is not going to allow you to pet my princess. You bastard! Figlio de putan. Sache tu sei un pizzo de mierda. You think you're cool, right? When you kick BlackBerry out of her house, I tell you this. 1 in 3 Americans is dying out of cancer. You know, asshole? You're going to be one of those. I didn't have the courage to kick your ass directly. Didn't have enough courage for that. But I could, you know? And so could BlackBerry. Did you know you're going to have another accident? You know I'm involved with black kittens? Fuck you. Die. Bastard. You think you're so cool, asshole. And if I ever see your fucking face around in Brooklyn or Manhattan, I'll kick your ass. Fuck you. Fucking American. Fucking Yankee. You're gonna die out of cancer. I promise. Deep pain. No one knows what you did to me. You want to know something? Fuck you. I want your balls mashed. Eat shit. Bastard. Pizzo de mierda. Figlio de putana. I hope somebody in your family dies soon. I hope that somebody in your family dies soon. Fuck you and your $2. Asshole. Thinking I'm going to whore my cat out to you for $2. What we need to do, the nerve, is check the gate as well as the source. Now, one of the difficult things here, because of Paul Daniels' software, and Paul Daniels' software just causes so many problems in life, is that the transistor is going to show up differently on the board than how it is in the program. So on the board, Q7010 has 4 solder pads on the left and 4 solder pads in the right in this configuration. However, in Paul Daniels' everything upside down dingo baby eating software, it has 1 pin on the top and then 3 pins on the bottom, which looks nothing like this. In what fucking world does this look like this, Paul Daniels? Really now? This isn't Paul's fault. These board views just suck. Okay, so here's what we're going to do here. So I don't know what the fuck the gate is. I don't know which one is the gate. So what I'm going to do is I'm going to measure something that I know is on the gate. So for example, the gate and the source are on each pin of C7012. C7012 is going to have 1 foot on the gate and another on the source. So if I can find C7012, even if there's nothing that is certain about this where things are on this transistor, I can know whether I'm measuring the gate or the source by clicking pin 2 or 1 or measuring pin 2 and 1 on the capacitor. So let's take a look at that capacitor and see what we're getting at these different points. Now, on pin 2 of the capacitor, which is supposed to be the gate, I get 18 volts. And on pin 1, I also get 18 volts. So of course this is not going to work. Now, I can't blame the transistor at that point. Can't blame the transistor because it's doing what it's supposed to do. P-channel. A P-channel transistor means that when you have the same voltage on the gate and the source, nothing's going to go through to the drain. Can't blame it. So now we got to see what's causing it to not make its way to ground. So, few possibilities here. Behind door number 1, C7012 has become short-circuited. Since this C7012 is no longer a capacitor, but acting as a wire, it is taking whatever's in the source and always bringing it to the gate all the time. Behind door number 2, R7011 has decided that it's going to die. Very unlikely. The reason it's unlikely is because R7011 is going to be what is carrying my 18 volts from the charger up here to the gate. That's unlikely. Behind door number 3, D7012 has died. D7012 is no longer allowing a path to ground, is no longer decreasing the voltage on the gate, and that's why the voltage on the gate is 18. So, I'm going to bypass thinking R7011 is my problem. I'm going to unplug power from the case, and then I'm going to measure the resistance between the 2 pins of C7012. Because if the capacitor has short-circuited and become a wire, this would be very apparent with a simple voltage measurement. And it has not, which means that the fault here is going to lie with the diode. So let's take a look at where the diode is. We're going to find this diode. Our Zener diode is D7012. It's right there. And what do you know? It has some green stuff around it. Now, is the diode itself bad? Or does the diode simply need a little bit of reflow? Now this actually looks like it's a fine pathway. What's corroded over here appears to be the probe point for me to test on. Watch, when I remove the diode, you'll see. So the pathway for the diode to go to the resistor is there. Thank you, JP. I appreciate that. And the pathway for it to go to ground is also there. So that was not our problem at all. Most likely this was just a bad diode. And being the madman that I am going to tap on the top of that diode. Is that too loud for you, games with C's? The fuck out of there, you little green solder ball. Little green solder ball invading my board like little green men invading Crimea. Get out of here! Okay. The fan spins. All along, all that was wrong with this liquid damage MacBook was a simple diode. That's all this MacBook needed. Was just a simple diode. This MacBook was picked at random. At no point in this process did Lewis pick his own machine from the queue, because that would be wrong. Wrong. That's it for today. And as always, I hope you learned something.
Yeah. Listen, how you talk about them and how you treat them post end of relationship. I will run you down. The light is green for me. Sorry, I'll show you on the GoPro what I was talking about.